Back in November of last year, Nicola gifted me a book called Dirt to Soil. And, it completely changed the way I was viewing gardening. Gabe Brown wrote the book, and I was fascinated about it enough to request that he come and share his knowledge about farming to us. It gave me a very great appreciation for the complex relationships that between roots, fungi, microbes, and the insects that are living in the soil. Everything that I knew about gardening changed from that book. And I'm pleased to welcome to the stage Gabe Brown, the author of this book, and who, along with his wife Shelly and son Paul, farms in North Dakota in a very smallish 5,000-acre plot of land, using entirely regenerative techniques, which means he doesn't use any herbicides, pesticides, any of that stuff on a large scale. Okay, so please welcome Gabe Brown.
Well, thank you. It's a pleasure to be here today. I'm a little bit out of my element. I'm used to walking around on the ranch with manure on my boots, and this is, needless to say, quite a bit different than that. So the first thing I have to dispel is the myth of where is North Dakota. So often people hear me be introduced that I'm from North Dakota, and they think that it's tundra and muskox. Well, actually, that picture there is not muskox, and it's not in the Arctic. That's on my ranch. That's 300 of our cow-calf pairs out grazing cover crops at 40 degrees below zero. Now, I actually felt a little guilty as I sat in the pickup and made my son walk out there and take that picture, but I made sure he made it back to the pickup and everything was okay. So now, you might be feeling sorry for the livestock. Well, don't feel sorry for them. They've learned to adapt, and they've learned to warm up in certain ways. So it doesn't always look like that on our ranch in North Dakota. There are a couple days in July that we do warm up, and it actually looks quite beautiful. That's the prairie in one of my native pastures back home. So you might ask, well, what do we have in common? What does a short, fat, bald rancher from North Dakota have in common with this group here? And I'm very, very fortunate in that in what I do, I have a lot of things in common with every person on this earth. We all breathe air, correct? This is the clean air back in North Dakota. And it comes about because of the way we operate our ranch. Another thing I have in common with you is water. We all require clean water, correct? And unfortunately, as I'm going to talk about, it's getting more and more difficult to provide fresh, clean drinking water all over the world. The other thing we need, of course, is nutrient-dense food. And I have the privilege of being able to produce, grow, and raise nutrient-dense food. As I'm going to show you, though, we no longer, as a society and as an industry, that of farming and ranching, we're no longer producing food that's high in nutrient density. One of the other things that we have to focus on is the factors that are affecting us. And one of those, of course, is climate change. And you can call it what you want, but carbon, we have way too much in the atmosphere, right? CO2, there's way too much in the atmosphere, not enough in the soil. Well, we've proven on our ranch we can regenerate that. We can pull massive amounts of carbon out of the atmosphere and put it back into the cycle, and it is a cycle, but right now there's too much in the atmosphere, not enough in the soil. We can change that, and we need to change it quickly because of things like this. This is a massive dust storm that took place in Texas just this past year. We should not be seeing things like that. Unfortunately, it's becoming more and more common, not less common. So I took this photo a number of years ago. That was my father-in-law, and I always say he practiced recreational tillage. He went out and tilled just for the sake of tilling, and I distinctly remember him telling me, Gabe, you'll learn the more you work the soil, the better it is. Well, that could not be further from the truth. Tillage is terribly destructive to the soil. Take a look at this photo here. On the left, that is a forested area. A farmer took part of the forested area, cleared the trees off, tilled it repeatedly, producing monoculture soybeans for 17 years. And that's the same soil there on the right. He degraded his resource due to his management, or as I like to call it, due to his stewardship. Now, if we were to look at that soil under a microscope, what do we see? Notice the soil on the left, the healthier soil, much larger pore spaces. That allows moisture to infiltrate. Biology lives in and on thin films of water in those pore spaces. Each one of those PEDs is called a soil aggregate. A soil aggregate will only last approximately 4 weeks, and then new ones have to be formed. And they're formed from a sticky substance called glomalin on mycorrhizal fungi and from the secretions of biology. In healthy soil, there's more microorganisms in a teaspoonful of healthy soil than there are people on this world. Yet how many of us, when we go out to plant a garden, we till the garden, correct? That's absolutely the worst thing we can do to produce nutrient-dense food. And we need to change that. We have a garden on our place that has not been tilled in over 25 years. We can do these practices without that tillage. I spent some time here in California this past winter, and we were on an operation, a farm in the Central Valley. And we were fortunate enough that the farmer allowed us to pick some of these soil pads. This is just a clump of soil. So one of these PEDs is from a conventionally farmed field. By that I mean large amounts of herbicides, whether it be synthetic fertilizer, pesticides, fungicides, herbicides, and tillage, monoculture grain production. They only produced one crop. Another one of the soil PEDs was from the organic farm we were on. That farm grew a wide variety of different cash crops plus cover crops, but they were still tilling. And then the third soil PED came from just a grass spot at the edge of the field. The amazing thing about this is all three of those were located less than 50 feet apart. Do you know which is which? The top one is from the grassed patch at the edge of the field. The middle one is from the organic operation that saw cover crops and a diverse crop rotation, but tillage. The bottom PED is from the highly intense farming practices that were done on that field. Now, the beauty of it is we have the ability through our management, through our stewardship, to regenerate that bottom soil back to the first one. And that's what I'm going to talk to you about. I'm going to talk to you a little bit about the journey my family and I have been on the past 25 plus years as we've taken dirt and changed it back, regenerated it into soil. One of the first things we had to do was get rid of the monoculture production. If you drive across anywhere in the United States or around the world for that matter, I've had the good fortune to be in many countries around the world, you see monoculture production. You know, in the United States, it's primarily corn, soybeans, cotton, and rice, those 4 crops. But wherever you go, it's monoculture. They're only producing one crop at a time. That's not how nature functions. Where in nature do you find monocultures? Usually only where man put them. That's not how nature functions. Because of this monoculture production and the fact that we've degraded and degenerated that soil, there is a need, some think, for high use of synthetic fertilizers. And that's come about, of course, since World War II. They took the factories that were producing nitrogen for bombs and created nitrogen fertilizer and started putting copious amounts of that out onto the land. That's further degraded the resource, as has the use of herbicides. You know, and many of you just heard that there was a $2 billion verdict came down here in California against the manufacturers of glyphosate for the damage that that's causing. A lot of those herbicides are water soluble. They go down the watershed. So with the monoculture production practices, tillage, this is what we see. We see an erosion of our soil resource. Those soils end up then in the watershed. A friend of mine took this picture out of an airplane. Look at the color of that soil. That's the soil of the water. That's the soil being washed down into the watershed. Along with it then, of course, comes all those applied nutrients, whether it be the synthetic fertilizers or the pesticides or fungicides, any of those others. That is negatively affecting, of course, our watersheds. Look at the dead zone in the Gulf of Mexico. It's ever expanding. The estuaries out here along the west coast, significant problem with the amount of nutrients that are coming into those watersheds. Speaking of the dead zone in the Gulf, the last 100 miles there that the Mississippi dumped before it dumps into the Gulf of Mexico, that's the highest cancer rates in the world are in that 100-mile stretch along the Mississippi. And it's due to the fact of all these chemicals that are being sprayed on the landscape. So, how about the food that this land produces? You know, it's often said that the United States is the land of plenty. Nobody should be going hungry. We produce plenty of food. But we need to look at the facts. The nutrient density of our foods has decreased anywhere from 15 to 65% in the past 50 years. It's really hard to find good data on this, but one study done by Thompson showed 27 kinds of vegetables. Look at the nutrients there. Copper declined 76%, calcium 46%, iron 27% decline, magnesium, potassium, every nutrient they tested for actually declined in those vegetables. It's not only vegetables and fruit, it's meat also. Sampled 10 kinds of meat. Look at that. Iron declined 54%. Most people believe you eat red meat to get iron. Well, you used to be able to. Unfortunately, with the confined animal feeding operations we have today, the nutrient density has declined. An individual today would have to consume twice as much meat, 3 times as much fruit, 4 times as much vegetables to get the same amount of minerals and trace elements compared to 1940. That's huge. What has that resulted in? The United States spends more on healthcare than any other country in the world. Yet we rank at the top or near the top in the instances of ADD, ADHD, Alzheimer's, Parkinson's, autoimmune diseases, osteoporosis, and I could go on. Why is that? Now, are farmers and ranchers to blame for all that? Absolutely not. Are we to blame for part of that? Absolutely. But every person out there is partially to blame for it because we drive farming and ranching by our buying dollars. What does the consumer want? We've had a cheap food policy in this country. Food price should be based on nutrient density, should not be based on just supply. This is Dr. Zach Busch. Dr. Zach Busch is one of the premier oncologists in the United States. And he spent his adult life determining cancer treatments for individuals. And he came to the realization a number of years ago that the best way to address the human health crisis is with nutrient-dense food. The only way to produce nutrient-dense food is with healthy soil. And a lot of the medical community is really coming around to understanding this. We have to start thinking of food as health, and we have to realize that it all depends on the soil that that food is grown or raised on. So on our operation, a number of years ago, we came to the conclusion that we had to mimic nature and follow nature's template. And if we did that, we would have a much more productive and healthy ecosystem. So if you look at nature, there's some rules that take place all throughout nature. So one of the reasons I get invited to travel all over the world and speak about this is because the template I follow can and does occur in every dryland ecosystem around the world. If you have soil and can grow things, these principles are the same. So the first principle is no mechanical or synthetic chemical disturbance. In other words, we don't want to till the soil, and we don't want to use all these added inputs, synthetic inputs. The second principle is armor on the soil surface. If you look at soil in nature, if you go out into a prairie, it's always covered. Nature is always trying to cover the soil, and it does that in order to regulate temperature, water, and to provide the habitat for the biology which cycles the nutrients. Nature cycles water very efficiently. We do not use water efficiently in agriculture anymore, unfortunately. And I can even say that about the water we use in the urban settings, on our lawns, golf courses, parks, etc. In nature, there's living plant root networks. Mycorrhizal fungi can cover thousands of acres. They form a symbiotic relationship with the roots of plants, and they transfer nutrients and water throughout the soil profile. The plant then feeds that mycorrhizal fungi carbon that it brings in out of the atmosphere, and in turn, that biology consumes that carbon, and then as it runs its life cycle, it provides nutrients for the plants. That's how the nutrient cycle works. And then the other thing is there's thousands of years of research and development in a natural ecosystem. Why do we as man think we know better and we can impose our will on nature? We're simply fighting nature all the time when we do that. So this is the sign I have at our driveway coming up to the ranch. I want people to know that we specialize in regenerative agriculture. So what is regenerative agriculture? This is Gabe Brown's own definition of it. It is a renewal of food and farming systems which aims to regenerate topsoil, increase biodiversity, improve the mineral, carbon, and water cycles, while improving farm, ranch, and community profitability, all while ensuring an enjoyable quality of life. I think all farmers and ranchers can agree that is a good goal to have. And the beauty of it is we can do that. One of my business partners, Ray Archuleta, made up this slide. And he made this statement a number of years ago, and I really believe in it. Plant and soil are one. We cannot have healthy soil without living plants. Now, I told you I spent quite a bit of time this past winter here in California. Driving through the Central Valley of California, it looked like a moonscape. I mean, there was nothing growing. How are we going to take carbon out of the atmosphere if we don't have things growing? In production agriculture today, we only grow things for a short window of time, and then the land is left idle. We have to get away from that, and we have to get away from the monoculture production practices. So here's what I'm doing on our ranch. This is just some of the crops that we grow. In the upper left, that's oats. And if you notice the green in there, there's 3 types of clover growing with that oats. It allows us to be able to harvest the oats, but we have a living plant there to take that carbon and other nutrients out of the atmosphere and pump it into the soil. In the lower left, that's corn, and there's hairy vetch and clover growing in with the corn. In the lower right, that's sunflowers, and I actually have 19 species of cover crops growing underneath the canopy of that sunflower crop. We can still harvest off the sunflowers, but we have this diverse ecosystem of life underneath. And that, in turn, is cycling the nutrients we need and pumping that carbon into the soil. In the upper right, that's a very diverse broadleaf forage mix. There's many different species in it. People travel all over the world and come to our ranch. We typically, on a typical summer, we get from 2,000 to 2,500 visitors. We've had visitors from every state, every Canadian province, and 24 foreign countries. And they come thinking they're going to see this earth-shattering difference. The only difference between my operation and others is that I grow things and I allow nature to function. One of the things we grow is diverse cover crops. So if we take off and harvest a cash crop, we will immediately go in there and seed a very diverse cover crop. It's made up of, in this particular one that I have in the photo here, there's 22 different species of plants growing. Now, what we're going to do with that cover crop, think of it, we're optimizing solar energy collection. Look at all the leaf sizes and shapes there are. And there's different rooting depths. There's shallow roots, medium, deep roots. We're bringing maximum amount of carbon out of the atmosphere, pumping it into the soil. And then we're going to graze those cover crops with livestock. And I know there's some who believe, oh, the cattle, we got to get them off the landscape. Removing ruminants from the landscape is absolutely the worst thing we can do. Think of how were our deep, rich soils formed over thousands of years. They were formed because of the relationship of a growing plant and a grazing animal. Once that plant is bitten by an animal, it sloughs off roots to attract biology so it can regrow, thus sequestering and collecting more carbon. We're able to pump much, much more carbon into our soils because of the grazing animals. So we run about 300 cow-calf pairs on our operation, and then we grass finish all the beef. And I'm very outspoken in that I am opposed to confined animal feeding operations. I often tell people, if you don't think an animal wants to be out of there, just open the gate and see what happens. They're going to leave every time. I guarantee it. They want to be out grazing. That's what their natural instinct is. Now, besides grass-finished beef, we raise grass-finished lambs. We have a flock of ewes, and we raise those lambs. We have pastured pork. Our hogs are never indoors. They're outside all the time, and we grow them out on pasture. We run about 1,400 land hens on pasture. We also do honey, and we do a vegetable production and grow a myriad of different cash and cover crops. All of these enterprises allow us to produce much, much more quantity and quality of the food that we produce. Besides that, we're a boon to wildlife. Our ranch is actually located in the city of Bismarck's jurisdiction. Bismarck is about 100,000 people, Bismarck, Mandan there. And our ranch is actually in city jurisdiction, but you couldn't tell it by the large amount of wildlife we have. We also have a tremendous insect population. Most people look at insects and they think of a pest, but do you know for every insect species that's a pest, there's 1,700 that are beneficial. We want insects on our place. And then besides that, we really focus on the life in the soil. And as I said, there's a tremendous amount of life in that soil. What have we been able to do then with our soil? The soil I'm holding there on the left, that's my soil from a cropland field. The soil on the right is the next door neighbor's cropland field. That's what I started with, was the same thing my neighbor had. But we've been able to regenerate it. Here's a close-up of, in 3 years, on one of our clients' operations, how we were able to regenerate that soil on his farm in just 3 years. Which of those soils has more carbon? Which is going to be able to infiltrate water? Which is going to be able to have the nutrient cycling to produce healthy plants? It's obvious. And we're doing this without chemicals and added inputs. This on the left, that's Dr. John Norman. Dr. John Norman is a world-renowned soil scientist. He actually invented a lot of the equipment that NASA uses to measure plant biomass from space. On the right then is Shannon Gomes from Cedar Basin Consulting, also a soil scientist. They set out to quantify what we're doing on our operation. So they pulled 140 different 4-foot probe soil samples, that's what you see in the tubes there, from all over our ranch. And Dr. Norman, after analyzing it, said that we now have 92 tons of carbon per acre stored in the top 4 feet of our soil profile. And obviously, as the soil gets healthier, we're able to store that carbon down to deeper and deeper depths. That's the equivalent of 60,400 tons of thermal coal. And we were able to do this in a very short period of time just using these natural principles. The soil cores showed aggregation, in other words, porosity, down to 4 feet. You know, so often people say, oh, we're in a drought. You know, here in California, I've been here several times over the past few years. Oh, the ranches we were on, they were suffering from drought. Well, so much of drought is man-made. It's not how much rainfall falls, it's how much can you infiltrate into the soil and then store there via the organic matter levels that you have. We now have an A-horizon topsoil of 29 inches compared to the neighbor's 5 inches. We're growing soil. Scientists used to say it takes 500 years to grow an inch of soil. That's not true at all. We can do it much, much faster than they used to think possible. So we're quantifying, the blue there is my ranch, we're quantifying all this data. We're finding that we can sequester 3 to 6 times more carbon than they used to think possible, even using the best management practices of no-till and cover crops. We like to think of it as the plant, the soil, plant, animal, and atmosphere continuum. That is natural capital. That's what we're trying to do. We're just trying to work with nature in order to give us the most efficient, productive system possible. Natural capital, then, is the primary infrastructure of civilization and the source of ecosystem services, including nutrient-dense food, reduced flooding and drought, clean water, clean air, and climate regulation. There's a real need out there by society for the services that farmers and ranchers are doing on their operations. We can make more plant-available water. We can have the streams flow. We can increase groundwater quality and quantity. We can have a cooling effect on that water and on our earth. We can vastly increase soil fertility without added amendments. Do you know that 97% of the nutrients found in a plant, if you were to dry out any plant, I don't care, tomato, cucumber, doesn't matter, dry that out, 97% of that is carbon, oxygen, hydrogen, and nitrogen. What do those 4 elements have in common? They're all in the air, right? Yet, so often as gardeners or farmers, we think, oh, we've got to add these amendments. No, we don't. We just have to follow the principles of nature in order to get them. There's an urgent need for reduced risk. We can reduce and mitigate these climatic factors that we're seeing around the world. You know, I was in Chico, California last year when the town of Paradise was lost. And unfortunately, a lot of that was man-made. Because of the lack of grazing animals on that landscape, that fire load was so high, all it took, you know, was just one small spark, and look at the devastation that was done. That could have been mitigated if we would have used these practices. So this is where you come in. You're wondering what this rancher has to do with this group. There's a real need to what I call land truth. In other words, prove what operations like mine that are practicing regeneratively are able to do out on the landscape. We need the instrumentation to be able to prove this. And we're starting to develop that. We would like handheld instruments that are able to tell us how much leaf canopy we have, able to tell us how much sunlight we're collecting, able to tell us how much biomass we have on our farms or ranches on any given day. There's a need for all this equipment, and I think we're going to rely on people like you to provide that equipment. I don't have the smarts to do it, but looking out in this room, I'll guarantee you that there's many people here that can do that. Then we need to be able to quantify the differences in nutrient density of food, correlating it to the health of the soil. There is a difference. One of those eggs is an organic free-range, quote-unquote, egg. The other one comes off my place. National Geographic came out, and they wanted to know if there was a difference. So I told them, okay, tonight you just go in and buy any egg you want in the grocery store. So they brought out a dozen organic free-range eggs, and then they went and pulled eggs out of one of our chicken tractors. That's the difference. There's a real difference in nutrient density. One of the groups I'm working on with is the Bionutrient Food Association. Well, the goal of ours is to have a handheld instrument, kind of like a card reader we can put on an iPhone, so any individual can walk into any supermarket or grocery store and scan the vegetables, fruit, other produce, and read the nutrient density of that product. That'll drive real change on the land. The other thing we need to do is to educate. And I'm part of a group called Soil Health Academy, where we actually go out and teach farmers, ranchers, and other individuals the importance of these regenerative practices in order to mitigate all the damages that we're seeing from climate change right down through human health. Thank you.